gears. A gear is a rotating cogwheel having cut teeth which interlock with another in order to transmit torque. Two or more gears when they work together in sequence form a gear train. The gear train has various advantages over belt pulleys. I. The teeth of a gear prevent slippage. 2. The speed ratio can be determined because it is constantly maintained. 3. Gears don't require large spaces compared to belt pulleys. 4. They can be used for a long time without wearing out, long lifespan. Types of gears: A. Bevel, B. Screw, C. Spur, D. Helical, E. Rack and pinion, F. Worm gears. There are other types of gears, but the ones listed above are commonly used. In order to drive a given load, there has to be a driving gear and a driven gear. The driving gear is the input gear and the driven gear is the output gear. The input gear should be bigger than the output gear so that the latter turns more quickly. The gear ratio is then obtained by measuring the ratio of the speeds of the two interlocking gears. In cases where we want to reduce the speeds and increase the torque, since most motors used in control systems have high rotating speeds and low torques, the gear trains termed as speed reducers are used. The mechanical of pair of meshing gear for which the input gear has N1 teeth and output gear has N2 teeth is given by N2/N1 equals T2/T1 equals speed ratio. This shows that the gear train amplifies the input torque if the output gear has more teeth than the input gear. And the gear train reduces the input torque if the output gear has fewer teeth than the input gear. If the output gear of a gear train rotates slower than the input gear, then the gear train is called the speed reducer. In this case, since the output gear must have more teeth than the input gear, the speed reducer amplifies the input torque. The mechanical advantage of the gear train is the ratio of the output torque T2 to the input torque T1. In a sequence of gears, there may be other gears interlocked between the first and the last gears. These are called the idler gears. These are intermediate gears. These gears reverses the direction of rotation of the output gears, but they do not interfere with the overall ratio of the chain. An idler gear is therefore an intermediate gear that is not connected to a shaft to drive it, but is in turn connected to other gears that may be interlocked to other gears which are connected to shafts in order to perform work. Idler gears can also transmit rotation among distant shafts in applications where it is impractical to make the distant gears larger. In order to bring them together, not only do larger gears occupy more space, the mass and moment of inertia is proportional to the square of its radius, R2. Instead of idler gears, a toothed belt of chain can be used to transmit torque over a distance.